Okay, I got a problem here. We're going to figure out the frequency drop when a NASCAR car passes at 90 meters per second, so about 200 miles an hour. The engine makes a true sound of 250 hertz. We're trying to figure out how high is that 250 going to sound when it's coming at you, how low is it going to sound after it passes, and then we'll subtract them and figure out what the difference is, and that's called the frequency drop. I've written down the information. We got the source, the car, is going 90 meters per second. We've got that the observer, doesn't say the observer is moving at all, so that's stationary. We've got the source frequency at 250 hertz, and I've got the Doppler equation right here. So we're ready to go. First thing I notice is I don't know V. This regular V, which is the speed of sound in air. So I've got to figure that out first. All right, I've written down the equation for finding the speed of sound at any temperature air, and I put in 20 degrees because it wasn't given. So I have 273 plus 20 on top, 273 on bottom, and when I punch this in the calculator, it rounds off to 343 meters per second. So now I have my V. And back to the equation over here. Fs is the frequency of the source, that's 250. V, I now know, is the speed of sound, which is 343. VO, nothing. The observer is just stationary. Vs is how fast the source is moving, which is 90 meters per second. So I'm going to have to plug it in and do the problem twice. All right, I've put all my numbers into the formula here. I got the frequency original, the source, I've got the speed of sound, I've got the speed of the car. I run it all through. Now I gotta be careful here. The calculator, if you should probably put this in parentheses in the calculator, or it won't do it first. So it should be 343 divided by the difference of 343 and 90. And then you should get what I got here, which is 339 rounded off. 339 hertz when it's coming at you. Now I know that's a possible answer because it's higher than the actual frequency of the car. When something's coming at you, it should be higher. Now I'm going to do for after it passes. Okay, I put in my numbers for when it's leaving. The only thing I had to change is I did not change the equation. It says V minus Vs. I have 343 minus, but I did put in negative 90 because when it's leaving, you use a negative number. So I put in negative 90, and now when I punch that in the calculator, I get a frequency of 198 hertz, which I believe could be a right answer because it's lower than the actual sound of the car. So now I can answer the final question, which is, what is the drop that is heard when that car goes by? And all I need to do is subtract 339 from 198, and the listener would hear a frequency drop of 141 hertz. That is the final answer.